Hello students and welcome back to my channel. In this video we will be discussing questions based on heat and thermodynamics, SHM and waves. Okay. So without wasting time, let us continue with this. As you can see, question number 20, the pressure of a gas changes linearly with volume from A to B as shown in figure. You can see the figure, students, here. It's a PV diagram. The figure is a PV diagram. Okay. So what happened? And if no heat is supplied or extracted from the gas, that means Q is given as 0. Then we have to find the change in internal energy of the gas. Change in internal energy we have to find. Obviously, students, this is based on the first law of thermodynamics. You can see first law of thermodynamics. But before plunging into that, we have to get the work done by the gas. Now, as you can see, work done by the gas is given by area below the PV curve. So what you have to do is, you have to reach the initial position, drop a perpendicular onto the volume axis, and then reach the final point, that is B, drop a perpendicular onto the volume axis. You will be getting a closed figure by all the sides. Okay, so area of this will give you area below the PV curve. And regarding the sign, if the gas is undergoing expansion, work done is positive. Whereas if the gas is being compressed, work done will be negative. So here you can see that the gas is being compressed because initial volume was how much? Initial volume was how much? It was 200 cc, whereas the final volume is 50 cc. So therefore, it is a case of compression. So work done by the gas will be negative. Okay. So let us calculate the value here. Work done by the gas will be, here you can see the figure is a trapezium. So if we will be applying the formula for area of a trapezium, that is half into sum of parallel sides. This side is 50 cc and this side is 10 cc. So 50 plus 10, that is 60 cc. 60 kilopascal. Kilo to be converted into this 10 power 3. So Pascal is Newton per meter square. Then multiplied by perpendicular distance between them. Perpendicular distance between them will be 200 cc minus 50 cc, that is 150 cubic centimeter. So cubic centimeter to be converted into meter cube by multiplying by 10 power minus 6. So meter square gets cancelled. You are left with Newton meter, which is joule. Okay. So this will be minus 6 by 2 into 15. I am separating the figure, students. Now here 10 power 1, 10 power 3, 10 power 1, that is 10 power 5 and minus 6. So 10 power minus 1. Okay, so 2 3s are. So we have minus 3 into 15 is 45 by 10, which is minus 4.5 joule. Okay. Now, writing the first law of thermodynamics, we have Q equal to W plus delta U. So Q is 0, W we got it as minus 4.5 joule, and we have to find the change in internal energy. So change in internal energy is plus 4.5 joule. Okay. So this is how you have to calculate. Now suppose, students, in the exam hall you forget the area of a trapezium. Then what we are supposed to do, the trick is, divide this into suitable number of rectangles or triangles. Squares, rectangles, triangles, you can divide this. And hopefully you know the formula for a triangle and a rectangle, isn't it? So accordingly you can find the total area as the area of individual rectangles and triangles. Right, moving on to the next question. The correct relation between gamma equal to Cp by Cv at temperature T is. Now for moderate temperatures, we all know gamma is only dependent on the degrees of freedom, that is the nature of the gas, its atomicity. If it is monoatomic, it is 5 by 3, that is 1.67. If it is diatomic, then it is 7 by 5, that is 1.4. And if it is non-linear polyatomic, it is gamma is 4 by 3, that is 1.3. All these things you know, students. Okay. So as per the question, we can say that Gamma is independent of temperature. But you have to always remember that at extremely high temperatures, a gas which is polyatomic, it could be diatomic, it could be triatomic, or it can have any atomicity more than one. It will dissociate into atoms at extremely high temperatures because the vibrations become so violent that the bond is no longer able to keep both all the atoms together in the form of a molecule. So the atoms will fly away from each other and the gas gets atomicized. That is, the molecules will get dissociated into individual atoms. In that case, atomicity will change because once the molecules get dissociated into atoms, the gas basically behaves as a monoatomic gas. And for monoatomic gas, it is always 5 by 3 gamma. So, at extremely high temperatures, gamma might change. For a polyatomic gas, gamma might change. But all those things we have to ignore here, it seems. Okay. Right. Moving on to the next question. Heat energy of this much is given to a diatomic gas, allowing the gas to expand at constant pressure. You can see heat is supplied at constant pressure, students. So basically, the thermodynamic process is a isobaric process. Isobaric process that you have to understand here. Then the gas molecule rotates about an internal axis but do not oscillate. Do not oscillate means there is no degrees of freedom corresponding to vibratory motion. Okay, there is no vibratory motion. You have to ignore vibration. That means we have to consider only the translatory and rotatory effect. So then degrees of freedom for a diatomic gas will be 3 corresponding to translatory motion and 2 corresponding to rotatory motion. Then we have to find the increase in internal energy. This is very simple question, student. We have to understand it here. We have to find the increase in internal energy. Increase in internal energy for any process, okay, is always equal to NCV delta T. Remember, students, increase in internal energy of an ideal gas for any process is always equal to this. And whereas we have been given that the heat is supplied at constant pressure, so at constant pressure means we will be using NCP delta T. Okay, NCP delta T. So if we divide equation 1 by 2, we'll get delta U by Q is equal to CV by CP. And CV by CP is 1 by gamma because gamma is CP by CV. Okay, so therefore I can write delta U upon Q is given as 735 joule. So 735 joule is equal to 1 by gamma. Now we all know that gamma is related to degrees of freedom in this. You have to remember this, students. Okay. So putting the value of degrees of freedom as 5. So we'll be having 1 plus 2 by 5, that is 7 by 5. So 1 by gamma is 5 by 7. Okay. So let us cancel this. 7 1s are 7 0 5. So while you multiply, you get final value as 5 into 105, that is 525 joule. So correct answer is the A option. Moving to the next question. For a solid rod, the Young's modulus is given as this and density is given as this, velocity of longitudinal. Students, this is simply formula based question. Okay. Now velocity of longitudinal wave is what? Velocity of longitudinal wave is given the under root Young's modulus upon rho. Okay. Young's modulus is given as how much? I can write this as 32 into 10 power 10. I have given 1 10 basically to this upon density is 8 into 10 to the power 3. Remember, I have substituted all the quantities in SI unit and I expect the answer in SI unit, which will be meter per second. So this will be 8 4s are 32. 4 into 10 power 10 minus 3 is 7. Since the power of 10 is not even, we have to convert this into it because we have to extract the square root. While extracting the square root, the power of 10 should always be even. So I am going to give 110 to this, so it becomes 40 into 10 to the power 6. So basically root 40 is 6 point something because the number which is a perfect square closest to 40 and less than 40 is 36. Square root of 36 is 6. So square root of 46 point something into 10 power 3 meters per second. So B option is the only option. Moving to the next question. A hypothetical gas expands adiabatically such that its volume changes from 8 liters to 27 liters. If the ratio of final pressure of the gas to initial pressure of the gas is this, then the ratio of 0. Now, first of all, you have to realize that the process is adiabatic. So we have to think of all the formulas related to adiabatic process. Here in particular, it is given that its volume changes from this to this, and also it is given that its final pressure of the gas to initial pressure ratio is given. In other words, we have to correlate the volume and pressure for an adiabatic process. So for any gas, okay, the relation between pressure and volume is this: PV power gamma equal to constant. So therefore, I can write in the initial state the product will be this, whereas in the final state the expression will be this. So therefore, I can write V1 by V2 whole to the power gamma is equal to P2 by P1. Okay, so V1 by V2, it's clearly given as 8 is to 27. Now P2 by P1 is given as 16 by 81. Now students, a little bit of common sense will enhance the problem solving ability, and immediately you will be able to solve the question. You see, 8 and 16 can be expressed as powers of 2, whereas 27 and 81 can be expressed as powers of 3. So 8 can be written as 2 cube, 27 can be written as 3 cube. So whole power gamma is equal to 16 can be written as 2 to the power 4, and 81 can be written as 3 to the power 4. So finally I can write in terms of 2 by 3. So this will be 2 by 3 whole power 3 gamma, and this will be 2 by 3 whole to the power 4. Now we know when bases are same, exponents can be equated. Is it? So equating the exponents, you have 3 gamma is equal to 4, so gamma is equal to 4 by 3. B option is the correct option. Moving to the next question. The maximum potential energy of a block executing SHM is 25 joule. A is amplitude of oscillation at a position A by 2 from main position kinetic energy of the block. Now maximum potential energy is also equal to the total energy of the system. So total energy is given 25 joule. Also amplitude is A, and at position A by 2 we have to find the kinetic energy. Okay. Right. Now what we can do is this. The formula for potential energy is more simpler than the formula for kinetic energy, and we also know that for conservative fields, kinetic energy plus potential energy is always equal to total energy. Remember students, simple harmonic motion is an undoubted example of conservative force field. A body executes SHM only in a conservative force field, because again and again the restoring forces have to bring back the body to its original position, that is mean position. So remember, so whenever you have a case of conservative force fields, you are always entitled to use the law of mechanical energy, law of conservation of mechanical energy. So here it is, yes, okay. So therefore kinetic energy can always be evaluated as total energy minus potential energy. Okay. Now total energy for a body executing SHM is this, half K into A square, where K is the force constant, and potential energy is simply half K into x square, where x is the displacement from the mean position. Okay. Therefore, so that means kinetic energy, you can use this formula half K into A square minus x square. This is how you calculate the formula. So we have to find this, okay, and we have been given this. Okay, so therefore equation 1 divided by 2 will give you K by E is equal to A square minus x square upon A square. Okay, so this will be here itself I will draw it. So this is 1 minus x by A whole square. Okay. So kinetic energy we have to find. Total energy is given as 25 joule. So we will be proceeding in joule, students. Okay. So 25 joule is equal to 1 minus x by A will be half, because x is equal to A by 2. So half square is 1 by 4. So this is 3 by 4. So from this we can write that K is equal to 3 by 4 times of 25 joule. Okay. So 4, 6.25 and 6 is 18, so 18.75 joule. So first option, A option is the answer. Moving to the next question. In the figure given below, a block of mass m equal to 490 gram placed on a frictionless table is connected with two springs. You can see the figure, students, on the right hand side of spring constant decimal. The block is horizontally displaced through x, then the number of complete oscillations in 14 pi seconds. So we have to find the number of oscillations. Let us say it is n in a time of 14 seconds. That's what we have to find. So before we proceed, we should be able to calculate the period of oscillation. And period of oscillation for a block connected with two or more springs, you can always use this formula. 2 pi under root n by k effective. Here you can see this resembles a parallel combination. Okay, so both the springs are connected in such a way that they resemble a parallel combination. So in parallel combination, the effective k can be calculated as k1 plus k2. So just add them. You have 2k. K is given as 2 Newton per meter. So 2 into 2 Newton per meter, we have 4 Newton per meter. Okay, so let us calculate this. So 2 pi under root mass is 490 gram. Remember, we have to proceed in SI units. So I am dividing by 1000 to convert it into kilogram, and K effective is 4. Okay, so we will calculate 1 0. We will cancel 1 0 here, and we are left with 2 pi. This is a perfect square. Square root of 49 is 7. Square root of 100 is 10. Square root of 4 is 2. So 1 2 gets cancelled. You have 7 pi by 10. No need to substitute for the value of pi as 3.14 or 22 by 7 because time is already given in terms of pi. So now that means if n is the number of oscillations executed, then the total time taken for n oscillations will be this. Is it? This will be the total time taken for n oscillation. This should be equated to 14 pi. So let us cancel 7 2s, 5 pi gets cancelled. So we have n is equal to 2 into 10, that is 20. So altogether 20 oscillations will be the answer. Okay, here students, it is just like calculating the number of copies which can be purchased for a certain amount. It is 14 pi is just like an amount, and you have to calculate the total number of copies which can be purchased. So first we have to calculate the cost of one copy. Is it? So this is cost of one copy. Time taken for one oscillation we calculated, and number of copies multiplied by the cost of one copy gives you the total cost required. So that's how we proceeded. Then moving to the next question, a water heater of power 2000 watt is used to heat water. The specific heat capacity of water is this much. The efficiency of heater is this much. Remember students, in such cases, you have to consider the effective power. Effective power is eta multiplied by power. 70% is 70 by 100 into 2000 watts. So this is the effective power. Okay, efficiency is not 100%. Then the time required to heat 2 kg of water from 10 degree to Celsius to 6 degree Celsius is seconds we have to find. Now we can calculate the heat required to carry out this process, and then also we can know the heat evolved by a certain heater in a certain time as power into time. So accordingly we can equate. So let us calculate the heat required. So heat required will be to raise the temperature of certain mass to a certain temperature is this. So mass of water is 2 kg. We are proceeding in SI unit students, so I am not writing the units. S is 4200 joule per kg Kelvin, and change in temperature is 60 minus 10, that is 50. Degrees Celsius and Kelvin are same as far as change in temperature is concerned. So no need to worry about this. So we have 42 to 10 power. 2 into 50 is 100. 100 into 100 is 10 power 4. This much joule is the answer, heat required. Also, if effective power is constant, then power multiplied by time will give you the energy release, which is in the form of heat here. So here this will be 7 into 1 0 gets cancelled into 2 T is equal to, okay. So we can equate these two. Simply we are supposed to equate these two to get the answer. So therefore, equating 1 and 2, you can see that when you equate these two, we have 7 into 2 into 10 power 2 into t is equal to 42 into 10 to the power 4. So therefore, what I can do is that 7 6 is 42, 2 3 is 10 power 2 divided by 10 power 2. So t will be 3 into 10 power 2, that is 300 seconds is the answer. Moving to the next question. The displacement equations of two interfering waves are given by this, and the amplitude of the resultant wave is. Now, this question is based on the principle of superimposition. So, as per the principle of superimposition, you can simply superimpose the displacement equations to get the total displacement equation. And students, principle of superimposition is nothing but vector addition. That's all. Okay. Principle of superimposition is nothing but vector addition. So simply we have to add them vectorially. But if you have a slight mathematical inclination, then you can simplify this and you will find that the expression will reduce to this kind of an expression. Let us see how it is. So we start from here. We have sine omega t plus root 3 into cos omega t. In trigonometry, we have studied that if you have to express this in the form of sine omega t plus theta, okay, then you have to multiply and divide by square root of coefficient of sine omega t square plus coefficient of cos omega t square. That is 2 root over 4 2. You have to multiply and divide by this. So I multiply 2 and keep it outside, and I divide with 2. That 2 I take it inside the bracket. So I have this. Okay. Now as you can see that this is actually cos 60 degree, and this is actually sin 60 degree. So therefore I can immediately write this as 2 sin A cos B plus cos A sin B is sin of A plus B. So that means y2 is 5 times of this. So y2 is 5 times of this. So 5 into 2 into sin omega t plus pi by 3, which is 10 times of sin omega t plus pi by 3, which is same as this y1. Okay, see, y1 and y2 are essentially the same thing. So according to principle of superimposition, resultant wave can be simply obtained by adding y1 and y2. So this is basically 2y1. So that is 20 times of sin omega t plus pi by 3. So the amplitude is 20 cm. So 20 cm is the answer. Okay. Then suppose you are not able to understand this, or suppose it doesn't strike, this kind of thing may not strike in the exam. In such a case, you can go with the usual method. The usual method is simply add them vectorially, because principle of superimposition, as I told you, it is basically vector addition. In other words, you have to add these two. So adding these two can easily be done vectorially. Okay. In such cases, wherever you have sine, okay, now take omega t as 0, and you have to ensure that all the things are converted into sine or cos, of course, but here you will be proceeding in sine. Take omega t as 0, okay, and convert all the things in sine. So if that be the case, then we can write, see here y1 is a vector having amplitude 10, making an angle 60 degree in the anti-clockwise sense from x-axis. I take omega t as 0, okay. So I'll draw y1 like this. This is y1. Treating omega t as 0. So plus 60 means, plus means in the anti-clockwise sense you have to move. Okay. Of course, the unit is centimeter. For y2, you have this 5 along x-axis and 5 root 3 along y-axis, because cos can be written as sin omega t plus 90. This cos can be written as sin omega t plus 90 degrees. So in the anti-clockwise, from x-axis, if you move a 90-degree angle in the anti-clockwise sense, you will reach y-axis. So we have 5 times along x-axis vector and 5 root 3 times the vector along y-axis. So this is y2. 5 along x-axis and 5 root 3 along y-axis. So this is y2. If you apply Pythagoras theorem, you will get 10 here. And this angle will be 60 degree. So basically both are one and same. Okay. Still, if you are not understood, then you can write like this. y1, vectorially y1 is 10 cos 60 degree plus sin 60 degree into j cap. Here y2 is 5 I cap plus 5 root 3 j cap. So you can see both are one and same. Both are one and same. Therefore, resultant as per the principle of superimposition is this. Okay. So 5 I cap plus 5 I cap is 10 I cap. 5 root 3 j cap plus 5 root 3 j cap is 10 root 3 j cap. Now, if you want the amplitude, then you can have this under root coefficient of I is 1, coefficient of j is root 3. So ultimately you have 20. 20 is the answer. Okay. So that's all students in this video. Thank you so much for watching my channel.